So we've talked about factory method operators, and just a very few of them. There's lots more. Let's now turn our attention to an example of a transforming operator. And the transforming operators in general transform the values and/or the types that are emitted by a mono. And we're going to talk here about the map operator. And I have fun animation here showing Optimus Prime transforming from a semi-ton truck cab to his transformer equivalent. So it's about transforming things and changing them somehow. So the map operator transforms the item that's emitted by this mono. So you can see here there's a map method, and this is going to look a little familiar to you, hopefully, because this is something similar to what we saw in streams. And what it'll do is it takes a function, which is literally a functional interface, and it'll apply that function to the item that comes into this mono, and it transforms it such that it comes in as one type, and it could leave as a different value of the same type. It could leave as a different value of a different type, and so on and so forth. It could come back as the same value of a different type. There's lots of different variations you can do. It all depends on the types that you use for the mapper. It returns a new mono that emits the results of the transformation. Now, as I mentioned before, you can use map to transform the value and/or the type of the element it processes, kind of like map in streams. You can go from one type and transform it into something else, like a caterpillar turns into a butterfly. And here's a very simple example. This builds on what we looked at before. If you recall before, we used the just factor method to get ourselves a reduced big fraction, and then that gets emitted by just, and then we use the fluent interface pattern that we've talked about many times before in the context of streams and completable futures to chain together the map method after the just method. And what map does is it applies the toMixString function, which converts the improper fraction, the improper big fraction, to a mixed string. So that's what that would do. And now we've also not only changed the value, but we've also changed the type, because up here it was coming out as a big fraction, and here it's coming out as a string. RxJava has something called map that's part of its single class that works exactly the same way. You will see that many of the operators in RxJava work equivalently to the way they would do in Project Reactor, but not everything works the same. So that's a little confusing. This is similar to Java completable futures, then apply method. We've seen this before. You're getting a chance to play around with stuff along these lines in programming assignment number 3, where we would go ahead and asynchronously reduce an unreduced big fraction using supply async. And then we're going to go ahead and convert that completable future to a big fraction into a completable future to a string. So this is very similar to what we saw before. The main difference between this use of completable futures and what we saw earlier when we were talking about monos and singles is this particular instantiation of mono with just and map runs synchronously. We'll show later how we make it run asynchronously. It does not run asynchronously by default. In contrast, a big difference between completable futures and Project Reactor and RxJava is that completable futures always run asynchronously. So supply async will always start things running in a thread from some pool, in this case the common fork join pool. Whereas with single or mono, unless you do something using an operator like subscribe on or publish on or so on, you're not going to have it run in a different thread. It'll run in the calling thread. So that's the end of the overview of one of the transforming operators in the mono class. We will come back later and talk about other transforming operators, but I'm doing these kind of incrementally so we can introduce the concepts and then get to a fun example to see how it all fits together.